students, let's learn most important concept of the lesson, and that is on latent heat of fusion. Very, very important definition. Now let's understand what is this latent heat of fusion by doing some small activity. Yes, so what are we going to do? Let's understand. In the beginning, we are going to take some crushed ice in a beaker. So first step that what we are going to do is we are going to arrange apparatus somewhat like this, and in this beaker which you see above, we are going to take crushed ice into it. Now after putting crushed ice in the beaker, suspend a thermometer in it. Of course, since we are dealing with temperature, we need thermometer. Note the temperature of ice. You just have to note temperature of ice. Of course, it is going to be 0 degrees Celsius. After noting temperature of ice, what you have to do is now heat the ice gently by using small flame of the burner. Not too hard, but the small flame of burner. Of course, what is going to happen is ice is slowly going to melt. So let's ask what is going to happen. As long as there remains even a little ice in the beaker, there is no rise in temperature, something which is very surprising, right? During the melting of ice. Let's go ahead. The latent heat or the heat which is going into the ice but not increasing its temperature is the energy required to change the state of ice from solid to liquid. This is known as latent heat of fusion for ice or of ice. Something which is most easy to understand. When the ice is in the solid form, the temperature remains as it is. Okay, and that is what is called as latent heat of fusion. Let's move ahead. This latent heat of fusion or melting of solid is the quantity of heat in joules required to convert 1 kg or 1 kilogram of solid at its melting point, that is to liquid, without any change in temperature is called as latent heat of fusion. Very, very important definition for 2 marks in your exams. Let's go ahead. The latent heat of fusion of ice is 3.34 into 10 raised to 5 joules per kilogram. Very, very important. Fill in the blank. This heat energy is used up. Now we are understanding why this happens. Why there is a latency. Okay, so let's understand by this answer. This heat energy is used up in changing the state of solid substance by overcoming the force of attraction between its particles. Let's move ahead and study something more about it. Okay, so ice at 0 degrees Celsius is more effective in cooling a substance than in water at 0 degrees Celsius. This is a fact about ice. For melting each kilogram of ice, it takes its latent heat of 3.34 into 10 raised to 5 joules from the substance, hence cools the substance more effectively. This is not so important. Remember, definition of latent heat of fusion is very, very, very important. Let's study something else about it. A piece of ice held in our hand feels very, very cold. This is the fact that we observe. Why? It takes latent heat required or for melting. Of course, whenever you take ice, it melts. Okay, now what is this is all about? It takes that latent heat required for melting from our hand. Our hand loses its heat and ice making us feel cold. Amazing fact about it, right? So now we know the reason behind it. It is all about latent heat of fusion. Let's move ahead and study the next concept, that is latent heat of vaporization. Very much similar to that of fusion with a little changes. Again, let us do some activity. Now here what are we going to do is, we are going to take water in a beaker. There it was ice, here we are taking water. Again, since we are dealing with temperature, we need thermometer. So our next activity is suspend a thermometer in it. After that, heat this water by using a burner. Slow flame burner. Remember that. The next step that we are going to do is note its temperature every after minute. Going on noting the temperature after every minute is very important thing to do it over here. Now, as the temperature rises gradually until it reaches 100 degrees Celsius, at 100 degrees Celsius, water boils and start changing into steam or in the gaseous state. As the heat supply is continued, we are not stopping the heat, we are continuously supplying a heat. There is no rise in temperature during the boil of water. The thermometer reading remains at 100 degrees Celsius. So we say for sure that boiling point of water is 100 degrees Celsius. It is because of this reason. Let's understand this in a better way. The particles of water attract one another with certain forces. These forces of attraction hold the water particles together in liquid state. But when we are heating, what happens? The heat supplied to water during boiling is used to overcome, this heat is used to overcome the force of attraction between water particles, so they become free. And when they become free, they change into a gas. So we know the reason why this happens. This latent heat does not increase the kinetic energy of water particles, and hence no rise in temperature takes place. Let's move ahead. These forces of attraction hold water particles together in the liquid state. The latent heat of vaporization of a liquid is the quantity of heat in the joule required to convert 1 kilogram of liquid at its boiling point to vapor or gaseous state without any change in temperature is what is latent heat of vaporization means. Latent heat of vaporization of water, let's understand it is 22.5 into 10 raised to 5 joule per kilogram. So we have learned two most important concepts in this module, that is latent heat of fusion and latent heat of vaporization. Let's understand what is latent heat of vaporization for certain examples, for certain liquid. Let's understand. For example, boiling point of water is 373 Kelvin. K stand for Kelvin. Alright, so 100 degrees Celsius is equal to 273 plus 100 degrees Celsius, which is equal to 373 Kelvin. So what we are doing over here is 100 degrees Celsius is the boiling point of water. We are converting that into Kelvin, and you know that you just have to add 273 in 100, so your answer comes out to be 373 Kelvin. Let's understand the most important concept, or what happens due to latent heat of vaporization, the effect of this soon. Now you all know, you have seen this picture. The burn caused by steam are much more severe than those caused by boiling water. This is amazing fact about it, and you know the answer for this now. What is the answer? Let's understand. Both of them are at 100 degrees Celsius. Water is also at 100 degrees Celsius and steam. But then why is the difference? Both of them are at 100 degrees Celsius. When water changes into steam, it absorbs latent heat. Steam contains more heat in the form of latent heat than the boiling water, and therefore the answer is this. Because of latent heat of vaporization, the burn caused by steam are much more severe than those caused by boiling water. Let's understand many more interconversion about the state of matter in the next module.